In this notebook, we'll cover the most important intermediate-level Python topics to prepare you for software development roles. We'll begin with object-oriented programming, where you'll learn about classes and objects, constructors, known as _init, instance and class variables, methods, inheritance, and method overriding. We'll also dive into encapsulation, private variables, and special methods like _string. Next, we'll move into file handling. You'll learn how to read and write text files, work with CSV files, and use context managers with the with statement. After that, we'll cover exception handling, including try and except blocks, the finally and else clauses, how to raise exceptions, and how to create your own custom exceptions. Then we'll explore comprehensions, where you'll learn how to use list, dictionary, and set comprehensions to write more concise code. We'll follow that with the powerful tools in Lambda, map, filter, and reduce, showing you how to write compact functional style code. Finally, we'll look at modules and packages. You'll learn how to create and import modules, how to use _init.py, and get an overview of the Python standard library, a huge set of built-in tools that come with Python.
Object-oriented programming, OOP. Classes and objects.
In object-oriented programming, a class is like a blueprint. It defines the structure and behavior that the objects created from it will have. Think of a class as a design and an object as the actual product built from that design. Classes contain attributes, which are variables that hold data, and methods, which are functions that define behaviors. In Python, you define a class using the word class, followed by the class name, and a colon. Inside the class, you usually define an initialization method called _init. That's short for _init. This method runs automatically when you create a new object from the class. To create or instantiate an object, you write the class name followed by parentheses.
Class constructor.
In Python, the constructor method is written as _init. It is pronounced as _init. This method runs automatically when you create a new object from a class. The main job of the _init method is to initialize or set up the attributes of the object. You can think of it as setting the default values or starting state of the object. The first parameter of the constructor is always self. This refers to the current instance of the class. In other words, the specific object being created.
Instance and class variables.
In Python, variables in a class can either be instance variables or class variables. Instance variables belong to individual objects. They are defined inside the _init method using the self keyword. Each object gets its own copy of these variables, so their values can be different for each object. On the other hand, class variables are shared across all instances of the class. They are defined outside of any method, directly inside the class body. Changing a class variable affects all objects that share it.
Methods.
In object-oriented programming, methods are functions that are defined inside a class. They describe the behaviors or actions that an object can perform. Just like the constructor, every method must include self as the first parameter. The word self refers to the current instance or object that is calling the method. You define a method just like a regular function, but inside the class. To call a method, use the object name followed by a dot, then the method name, and parentheses.
Inheritance.
Inheritance is a key feature of object-oriented programming. It allows one class, called the child class or derived class, to inherit the properties and methods of another class, called the parent or base class. This helps in reusing code and makes your program more modular and organized. To create a child class in Python, write the class name, followed by parentheses with the name of the parent class inside. The child class can use the methods and attributes of the parent class, and it can also define its own.
Method overriding.
Method overriding is when a child class defines a method with the same name as one in its parent class. This allows the child class to replace or customize the behavior of the method it inherited. Overriding is useful when you want most behavior from the parent class, but need to change specific parts in the child class. To override a method, simply define a method in the child class using the same name as the one in the parent. When the method is called on an object of the child class, Python will use the child's version.
Encapsulation and private variables.
Encapsulation is the concept of keeping data and the methods that operate on that data bundled together inside a class. It also means hiding the internal details of how something works, so it's only accessed in controlled ways. In Python, we use double underscore before a variable name to make it private. This tells other parts of the program that the variable should not be accessed directly. Instead, we use special methods called getters and setters to safely access or update private variables. This helps protect the integrity of the data and adds an extra layer of control.
The dunderstr method.
The dunderstr method defines how your object should look when it is printed or converted to a string. Without it, printing an object just shows its memory location, which isn't helpful. By defining dunderstr, you can return a clear, readable description of your object, just like built-in types. This method must return a string, and it's automatically called when you use the print function or the str function on your object.
The dunderlen method.
The dunderlen method, spelled as len, lets you define what the built-in len function should return when called on your custom object. This is especially useful for classes that act like containers, such as collections, groups, or lists. Just define the method inside your class and return an integer that represents the length or size.
The dundereq method.
The dundereq method is used to define how two objects should be compared using the double equals operator. By default, Python compares object identity, not their contents. But when you define dundereq, you can customize this to compare attribute values instead. This method must return a Boolean, either true or false, depending on whether the objects should be considered equal.
Other magic methods.
Python provides many other special methods, also called magic methods or dunder methods, that let you define how your objects behave with operators, indexing, comparisons, and more. For example, dunderAdd defines how the plus operator works for your objects. DunderLT is used for less than comparisons. DunderGetItem lets you use square brackets to access elements. DunderReaper returns an unambiguous string that developers can use for debugging. You can override these to give your class custom Pythonic behavior.
File handling. Reading text files.
To read a text file in Python, use the built-in open function with mode set to R, which stands for read. You can use the read method to get the entire content as a single string. The readLine method reads one line at a time, and readLines returns a list of all lines. It's important to close the file after you're done. A better practice is to use the with statement, which automatically closes the file for you.
Writing text files.
To write to a text file, open it with mode W for write or A to append to the end. If the file doesn't exist, Python will create it. If you use W, it will overwrite the file if it already exists. You can use the write method to write a string or write lines to write a list of strings. It's best to use the with statement, so the file closes automatically.
More about with statement.
The with statement in Python is used for resource management, especially useful when working with files. It ensures that resources like file handles are properly closed, even if an error occurs during processing. When you use open inside a with block, Python will automatically call the file's close method when the block ends. This makes your code safer and cleaner. You can also use multiple with statements in one line to manage several resources together.
Working with CSV files.
CSV files, or comma-separated values, are one of the most common formats for storing tabular data. In Python, we use the built-in CSV module to work with them. The CSV reader reads each row as a list, while the writer lets us write rows easily. If your file includes headers, you can use CSV dict reader and dict writer to work with rows as dictionaries, using the column names. CSV files should always be opened in text mode, usually with mode R for reading and W for writing.
Exception handling. Try, except.
Python uses the try and except blocks to handle errors gracefully. Code that might raise an error is placed inside the try block. If an error occurs, Python jumps to the except block. This helps prevent crashes and allows your program to recover or show a friendly message. You can catch general errors or specify the type of exception to handle specific problems, like file not found or division by zero.
Finally, else.
In Python's exception handling, you can add two optional blocks, else and finally. The else block runs only if no exception is raised in the try block. It's useful for code that should only run when things go smoothly. The finally block runs no matter what, whether an error happens or not. It's often used to clean up, like closing files or releasing resources. These blocks give you more control over your program's behavior, especially when managing resources or logging outcomes. Let's see an example that uses try, except, else, and finally together.
Raising exceptions.
Sometimes you'll want to raise an exception on purpose. For example, when input is invalid or a rule is violated. In Python, we use the raise keyword to do this. You can raise built-in exceptions like value error or type error, and you can include a message to explain what went wrong. This helps make your code safer, clearer, and easier to debug. You can also define your own custom exceptions, which we'll cover later.
Creating custom exceptions.
In Python, you can create your own exception types by defining a new class that inherits from the built-in exception class. Custom exceptions are useful when built-in ones don't clearly describe the problem. For example, if you're building a banking app, you might want to raise an insufficient funds error instead of a generic value error. You can raise your custom exception just like any other and include custom messages to help the user or developer understand what went wrong.
Comprehensions. List comprehensions.
List comprehensions are a shorter and more readable way to create lists in Python. Instead of writing a full for loop, you can use this one-line syntax. Open bracket, expression for item in iterable, optional if condition, close bracket. They're not just shorter, they're also faster and easier to understand once you get used to them.
Dictionary and set comprehensions.
Just like list comprehensions, Python also supports dictionary and set comprehensions. A dictionary comprehension uses curly braces with a colon between the key and value. A set comprehension looks similar to a list comprehension, but uses curly braces and does not include key-value pairs. These are great for quickly building collections while filtering or transforming data.
Lambda, map, filter, Reduce. Lambda.
In Python, a lambda function is a small, anonymous function, meaning it has no name. You define it using the lambda keyword. The syntax is simple. Lambda, arguments, colon, then a single expression. Lambda functions are commonly used when you need a quick, one-time function, often inside functions like map, filter, or sorted. They can take any number of arguments, but must have only one expression.
Map.
The map function in Python lets you apply a function to every item in an iterable, like a list or a tuple. It returns a special map object, so if you want to see the results, you'll usually convert it to a list. Map is often used with lambda functions for quick one-line transformations. For example, squaring every number in a list.
Filter.
The filter function in Python is used to select items from an iterable that meet a specific condition. It takes two arguments, a function that returns true or false, and an iterable. Only the items where the function returns true are included in the result. The result is a filter object, so we usually convert it to a list to view or use the values. Lambda functions are often used with filter to keep the code short and readable.
Reduce.
The reduce function is used to apply a function cumulatively to the items of an iterable, reducing the sequence to a single result. It's not built in. You'll need to import it from Python's functionals module. Reduce takes two arguments, a function that takes two inputs, and an iterable. It applies the function to the first two items, then to the result and the next item, and so on, until one final result remains. This is useful for tasks like calculating a total, finding a product, or chaining operations.
Modules and packages. Creating and importing modules.
In Python, a module is just a file with a .py extension that contains code, functions, variables, classes, anything you can define in Python. You can reuse code by importing it from another module. Just use the import keyword followed by the file name without the .py extension. If you only need certain functions or variables, you can use from module import name. You can also use as to give an alias to a module or item, making it shorter or more readable in your code.
Using init.py.
The double underscore init.py file is used to mark a directory as a Python package. In older versions of Python, this file was required to treat the folder as a package. While it's technically optional, in Python 3.3 and later, it's still very useful. It can be empty, or it can include initialization code, define what modules are available to import, and simplify access to submodules. This is especially helpful for organizing large code bases.
Installing and using third-party packages.
Python has a massive ecosystem of third-party packages, reusable tools and libraries created by the community. To install these, we use pip, which stands for Python Installer Package. The basic command is pip install, followed by the package name. Once a package is installed, you can simply use the import statement in your code to access its features. You can view installed packages with pip list, get details with pip show, or remove a package using pip uninstall.
Python Standard Library Overview.
The Python Standard Library is a collection of built-in modules that come packaged with Python. This means you can start using them right away, no need to install anything. These modules cover a wide range of common programming tasks. For example, math for mathematical functions, datetime for working with dates and times, OS for interacting with the operating system, random for generating random numbers, JSON for reading and writing JSON data, and sys for accessing system-level information. To use one, simply write import, followed by the module name. Thanks for watching.